Mobile devices have become ubiquitous, but many of them still remain oblivious to the abilities of their users. Meanwhile, developing ability-aware apps requires extensive effort, which can be impractical on an individual developer basis. Therefore, we present the Ability-Based Design Mobile Toolkit that enables developers to make interface adaptations based on user-situated abilities at runtime. Conceptually, the ABD-MT allows developers to engage with a user's ability profile, which is dynamically built up during runtime. The ABD-MT framework consists of three main parts: the observers, the ability modeler, and the UI adapter. The observers capture a user's input events and sensor data currently regarding a user's touch, gesture, physical activity, and attention. Each observer also provides API methods that calculate basic metrics regarding each ability. Synthesizing the observed input events and sensor data, the ability modeler exports a set of methods to provide a higher-level, holistic understanding of the user's abilities and allows the developer to inspect these abilities. With this information, a developer can then utilize the UI adapter methods to adapt the mobile interface according to the observed abilities at runtime. To evaluate the ABD-MT, we first built 5 example applications, all enabling the ability-based functionality with just a few lines of code. We first built a password entry interface. When a user is detected having tremor, the widget is enlarged to have minimum width and height of, for example, 4 times the touch extent of the user. Then, we built an adaptive Pokemon game in which a user drags and throws a Pokemon ball to catch a Pokemon creature. When the user is detected walking while using gestures, the camera button is triggered to turn on an AR experience, and the target Pokemon is brought closer to let the user more easily reach it. We also built an app that by default displays a typical small notification, but when the user starts running, it displays a larger notification with more detail and keeps enlarging if the user fails to click on or dismiss the message. We then built a text editor. That zooms with fat fingers so that the user can more easily place the cursor, and reverts back when the user finishes editing. Finally, we built an adaptive reading app that turns its brightness up when the user is looking at the screen and dims the screen when they look away. We compared the lines of code required for each app with and without our toolkit and found that there is a substantial reduction. In addition to the example apps, we also ran a study with 11 programmers who had Android development experience. During the study, participants were all able to implement ability-based functionality of mobile apps within a short amount of time. Our study also shows that the toolkit is easy to learn, easy to use, welcome for future use, and applicable to a variety of end-user scenarios.